All right, hello everybody, and welcome to the first lecture in the last unit of the chemistry section of our course, also known as the first quarter. And this is going to be talking a bit more about solutions. Okay, so you may remember these from the first unit. This is sort of another name for homogeneous mixtures that involve something dissolved in a liquid, usually either a gas or a solid being dissolved in a liquid. And so we're going to talk a little bit more about those, specifically solubility. So, first of all, there aren't any notes associated with this, but I just want to briefly talk about how a solid actually dissolves in a liquid. Okay, so we've got over here this kind of big block, and you can see it's made of sodium and chlorine. So you should remember that this is salt. This is a block of salt in its solid form. And the way that it is dissolving is shown here, where water molecules, which are shown here, a water molecule has sort of a positive side and a negative side. Right, the hydrogens kind of make a positive, and the oxygen kind of makes a negative on the other side. And so water molecules are able to kind of surround, with their negative sides, attract this positive sodium ion here and kind of grab it and just kind of yank it off of the block of solid sodium chloride and just kind of carry it out into the solution as just a lone ion that is surrounded by water molecules. And then they can kind of flip around and do the same thing to the negatively charged chlorine ions, which is what's shown right here. Right, so that's negatively charged chlorine with the positive side of a bunch of water molecules surrounding it. Okay, so this is just the atomic level explanation of how something actually dissolves in water. Okay, so this is a little review just from the first unit. Solvent, remember, is the liquid that is dissolving something, and solute is the thing that's being dissolved in the liquid. Okay, solute can be a gas, liquid, or solid. Most of the time we're going to be talking about solids and just a few gases. Okay, and solutions follow this logic, this sort of principle called the like dissolves like. All right, and basically what this just means is that things that are polar, like water, like what I was talking about before with the water molecules having a positive and negative side to it, that's called being polar. They are good at dissolving things that are polar, like ionic compounds that have a negative and positive ion, and other things like, you may remember from the lab, this sort of has a bunch of negative points on it and positive points elsewhere, and this is sucrose, which is sugar. And sucrose also dissolves in water quite well. Things that are not good at dissolving in water are things that are non-polar. Like down here, this is just, a very basic kind of repeating structure that doesn't have a lot of pluses and minuses on it. This is octane. But things that kind of look like this are, for example, oils look like that, and that is why you can't really dissolve an oil in water. They just separate into two layers. So that's the concept of like dissolves like. Excuse me. So next up, we'll talk about what it means for a solution to be saturated. Okay, so saturated solutions is just when you take a certain amount of water and you dissolve as much as can possibly be dissolved into it. Okay, so if you add any more, it's just going to float to the bottom of the beaker or whatever container you're using and just sit there. It's not going to be able to dissolve into the water because basically the water is full of whatever has dissolved into it. And in fact, it's not called being full, it's called being saturated. Okay, so saturated solutions contain as much solute as is possible, as much as can be dissolved. Unsaturated solutions can dissolve more, aka they have less than the saturated amount. So you can put more in there and it can still dissolve. Supersaturated solutions are the opposite. They have dissolved more solute than is normally possible at that temperature. And you might ask, how can you possibly do that? Well, the amount that can be dissolved changes with temperature, as we'll see. So you could heat something up, dissolve a bunch of stuff in it, and then cool it back down, and at least for a while, it will not come back out of solution. Okay, so this is what is done, for example, when you're making like candy. You dissolve a bunch of sugar in there, and then while it's heating up, and then you kind of boil off the water, and it becomes more and more and more concentrated until it kind of crystallizes out. Alright, so to demonstrate this, we have these things called solubility curves. So what these show, you can see on the y-axis, we've got grams of solute per 100 grams of water. So this is basically saying on the y-axis how much will dissolve in 100 grams of water. And on the x-axis down here, we've got temperature. Okay, so as an example, and these different lines are all just different substances. So looking at sulfur dioxide down here, all right, you can see that it, at 0 degrees Celsius, right here, about 25 grams of it will dissolve in 100 grams of water. But then if you heat it all the way up to 100 degrees Celsius, which is the boiling point of water, then only, less than 5 grams will dissolve in it. This is a gas, by the way, which is why it behaves like that. Typically, gases kind of have a, let me get my orientation right. Gases kind of have a downward slope on this graph, and solids have an upward slope. Like, you all might be very familiar with the fact that if you want to dissolve more stuff in water, you need to heat it up. Okay, but the opposite is actually true for gases. Okay, so just using the nomenclature we just talked about, at any point on this line, that is the saturation amount. Okay, so right here at about 50 degrees, saturation amount for potassium nitrate is about 80 grams. And so if it's at this temperature and there's more in there, that means we're supersaturated if we're above the line. And if there's less in there, that means we're unsaturated when we're below the line. Okay? So let's do some practice here. Just reading this graph. All right. How many grams of NaCl, sodium chloride, will dissolve in 100 grams of water at 90 degrees Celsius? So you can see it's talking about 90 degrees. And it's talking about NaCl. So let's find NaCl. Here it is, down here. And it's on this like very flat line, which is kind of unique. You can see that most other ones, the line isn't very flat. And we want to know about it at 90 degrees. So that's down here. So we draw our line up to where the line intersects at 90 degrees. And then we read that off the y-axis. So that dot lines up pretty nicely with the 40 line. So I would say, for an answer here, 40 grams of salt will dissolve in 100 grams of water at 90 degrees Celsius. All right. Next up, how many grams of potassium chloride will dissolve in 100 grams of water at 30 degrees? Okay, so once again, we're talking about potassium chloride, 30 degrees. So we find potassium chloride, that's this line right here. And we want it at 30 degrees. So we follow the line up until we hit it right there. And then we kind of go to the side and see where it where that point is on the y-axis. And it's probably about at 35 grams. So 35 grams of KCl will dissolve in 100 grams of water at 30 degrees Celsius. 30 degrees Celsius is like hotter than room temperature, but not like absurdly hot. Like it is regularly hotter than 30 degrees Celsius outside in North Carolina. All right, last one. How many grams of KCl will dissolve in 200 grams of water at 30 degrees? So this is the same question, except it's asking about 200 grams, right? So we've actually already read the number off the graph for 100 grams at 30 degrees, but how many will dissolve in 200? Well, if we're doubling the amount of water, then all we have to do is double the amount that is dissolved in it, because it's got a nice linear relation like that. Okay, so if 35 grams dissolves in 100, then 35 times 2, which is 70 grams, will dissolve in 200. Okay, if it was asking about 50, then we would cut it in half. Okay, and so it would be, 17.5 grams per 50 grams of water. All right. So just be aware that you can be asked about things that will dissolve in not just 100 grams, but potentially any other number, and you'll just have to do a bit of math to get there. But mostly this is just standard reading a graph material, and we're not really going any more in depth into the concept of solubility. This is just a little bit of intro to this unit when we're going to be talking about acids and bases and chemical equations and stuff like that. So that is all. Won't drag it out any more than this. I will see you in class.